Hi girls, I'm going to take a look at the homework that I set you where we're starting to take a look at alkenes. And just to go back on the previous homework, I'll post that video for you now when I'm waiting on just a few more people to come back with their work. 21.1 part C and D seem to be the ones that cause the most trouble. You're not naming them wrong, it's just you're making it more challenging for yourself than you need to. So just take a look, make sure you focus in. I gave you those of you who had submitted some feedback, that's the one that you need to take a look at. You're probably waiting on the video, it will come soon though, girls. Okay, the next ones we were taking a look at was the alkenes. So again, the difference between an alkane and an alkene has this double bond, and this double bond then gives it all sorts of new abilities, which we will take a look at next year. And the double bond here makes it these compounds be known as unsaturated. So unsaturated simply means that they have an area where we could add something on, and they can do addition reactions as opposed to just substitution reactions, which is what you get for alkenes. So I asked you to take a look at pentene and hexene for your homework. So when we look at pentene, pentene can have pent-1-ene, so that's where the double bond is between carbon 1 and 2, and pent-2-ene where it's between carbon 2 and 3. There's no other options, because if I move this double bond to here, then we start to number it right to left, so that'll be 1, 2, so it's still carbon pent-2-ene. If I move this one to here, it's still pent-1-ene, because we would number it then 1, 2, 3, 4. So there are only two structural isomers for pentene, and that is pent-1-ene and pent-2-ene. Just to finish it off then, to put the bonds around it, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And there are the hydrogens in around it. Okay, and you could do the same then down here with the next one. If we take a look at hexene then, hexene does have 3 isomers. So you've got 6 carbons in a row. I could have hex-1-ene, and that's where the double bond is at carbon 1. It could be either here or here, and that's the same structure, just flipped across or turned. So it's the same hand, same thumb, same little finger, and now I flipped it. They're still the same, they're just orientated slightly different. So the thumb's on the right hand side instead of the left hand side. They're what we call mirror images of each other, so they're not isomers, they're just different ways of arranging themselves. So hex-1-ene is where you've got the double bond at carbon 1. Hex-2-ene is where you have it at 2. It could also be here, that would also be hex-2-ene. And then there's one here called hex-3-ene where the double bond is in the middle. Okay, and then you fill them in and around with the hydrogen. So if you take a look here, there's 3 hydrogens there, 2 hydrogens there, 1, 2, 3, just one there, 1, 2, 3, one there, 1, 2, 3, 4, 1, 2, 3, 4. Okay, and if we take a look at their formulas, both of these are the same. So you've got C5H, and if you count the hydrogens there will be 10, and C6H12, because you always double the number from carbons to hydrogens. So the work I'm going to assign you now, girls, is 21.3 and 4 in your book. So 21.3 and 21.4, and that's in your textbook. And then we'll come and take a look at the workbook ones if you're still having difficulties with the textbook ones. So this is an example of one similar to what you've got in the book. So it asks you to name the structure. So the first thing you have to do is draw it out. So a carbon with 3 hydrogens, a carbon with 2 hydrogens, a carbon with 1 hydrogen and a methyl group, a carbon with a hydrogen, a double bond, and a carbon with 2 hydrogens. Okay. So if we take a look at the longest chain, we've got 1, 2, 3, 4, 5. So we're looking at pent. We're looking at where the double bond is. So we're going to number it this way. 1, 2, 3, 4, 5. So that the double bond is as near to the end as possible. So this is pent-1-ene. And it's not regular pent-1-ene. There is something on carbon number 3 that is unusual. So it's 3-methyl pent-1-ene. So it's exactly the same as the alkane, except you do have the extra thing of telling me where the double bond is. Okay, and the 21.4 questions give you the name and ask you to work back. So we're looking at hept-3-ene. So we're going to go with, now I made this up so I'm not sure if it works. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, or we can go 1, 2, 3. So it doesn't matter where we put it. So we'll pop it there. That would be normal heptene. So we would normally fill it in with hydrogens. So 1, 2, 3, 4, 1, 2, 3, 4, and then the normal. And it's telling me at carbon number 2, so I've numbered it this way. So at carbon number 2, there is CH3 and a CH3 because there's 2 2s. There are 2 2s. And then at carbon number 4, again, we have a CH3. So that's what the compound would look like when it's drawn out. And obviously there's hydrogens all the way around here. Okay. So that leaves you with 21.3 and 21.4 in your textbooks for homework. And I'm trying to remember when we had class. No, we have class all the way to Thursday. So this will, I'll put the due date on the assignment when I figure out what that date is. Okay. And I'll talk to you then. Take care. Bye.